and then we'll get into some where you guys are just kind of working together. So the first thought is the x-intercept is where ... Remember, we're talking about lines in our chapter here this time. So what do you think the x-intercept would be as far as the graph of a line? Yes, Will, what do you think?
Well, like where the line crosses the x-axis.
Where the line crosses the x-axis, that's right. So let's fill that in. Where the line crosses, technically all it has to do is touch, but we'll say crosses the x-axis. I like it. So then, based on Will's good thought process there, what would you guys guess the y-intercept is? It is where? Yeah, the line crosses the y-axis. So let's fill those in. And what I want you guys to do here now is work with your table partner, and I want you to identify the x and the y-intercepts. And in doing so, I want you guys to identify them by using x, comma, y. So please don't just say like the x-intercept is 10 or the y-intercept is -9. Say the x-intercept is 10, comma 0, right? And the y-intercept is 0, comma 9, or whatever it happens to be. So please try that for A, B, and C. Work with your table partner. Write it down. Just label the x-intercept and y-intercept for each of these lines. Ready, set, go. Testing responses. Let me give you the first answers here for, we'll just work on A. Wouldn't it be fair to say that our x-intercept is right about there and our y-intercept is right about there, just on a graphing, from a graphing perspective? So what I'm going to say then is right here, that is my x-intercept, and my x-intercept is at -4, comma 0. Left 4, and then up and down nothing. Does that make sense?
Yes.
Okay. And then my y-intercept is that one right there. My y-intercept is left and right 0. I didn't go anywhere left or right, but I did go up 1, so it'd be 0, comma 1. Sorry, that kind of went off the edge there. Can you still see that okay?
Yeah.
This is the x-intercept. That's the y-intercept. There we go. Okay, so now please look at what you responded with for A. If what you responded with is right on the money, then awesome. If you responded, I saw some folks, plenty of folks actually, that wrote this. They wrote something like, I don't know, that just down below they wrote -4, comma 1. Do you see how somebody might put that? It's not right, because -4, 1's not even on the line itself. But what they're doing is they're listing the x-intercept as the x-coordinate, and the y-intercept as the y-coordinate, and that's just simply not right. Some folks are saying, oh, maybe it was like kind of a slope idea, which we'll talk about soon. It's not that either. And so -4, 1 really isn't even on the line, so it's got to be the format that we've got up there. Does that make sense? Does anybody need just a second to maybe adjust your answers for B and C?
Yeah.
Raise your hand if you want maybe just another minute. Okay, let's check it out then. So for B doesn't have one of them, right? Which one does B not have? Yeah, it doesn't appear to ever cross the x-axis. It looks like it's parallel to it. So I would say that there is no x-intercept, but the y-intercept would be 0, comma -2. You guys have the same thing? Okay. It's not -2, 0, right? That's something else. 0, -2 would be the y-intercept. And then lastly over here on C, I do see both of them. I see an x-intercept there and a y-intercept there. So my x-intercept is going to be at, let's see here. Let's try that again. -1, comma 0. And my y-intercept would be at 0, comma -3. All right, so you guys have any questions? That go okay? You guys get the notation right with 0, comma this or something, comma 0. Okay, good deal. Well, let's answer these questions then. At the x-intercept, the y-coordinate always is 0. And at the y-intercept, the x-coordinate is always 0. That's kind of the point of that exercise right there. And that's going to help us as we move forward and finish out this section. So before we do that, do you guys have any questions at all? Okay, let me remind you, let's remind ourselves, what is chapter 3 pretty much all about? It's about one topic only.
Graphing.
Graphing, specifically
Points on the graph.
points on a graph of a, or slope on the graph of a line. Somebody said line, right? Lines have equations, lines have points, lines have slopes. This is all about graphing the equation of a line. Okay? So let's take a look at how we could do a little graphing with this right here. So we're going to do number 2 together, and then the next couple I think I'm going to have you guys work on. So this says use intercepts to graph, and gives us this nice linear equation over here. I want to ask you guys a question. How many points does it take to define a line? How many do you need to define a unique line? 2, right? Yeah. So if I know that there's a point here and a point there, that's going to define one unique line, right? So here's my thoughts on this. If I could find the x-intercept, and then if I could find the y-intercept, don't I have 2 points that are on the line? I would have the line, wouldn't I? So you're going to find, those of you that are like really, and I know it's very, very typical, that those of you that have some kind of algebra background from middle school, you've really been trained that slope-intercept form is the only way to do it, or it's the best way to do it, or whatever. In certain cases, what we're about to do is better. Way better. So check this out. We're going to use intercepts to graph. I am going to find my x-intercept first, and here's how we're going to do it. We're going to find our x-intercept by using the thing that you all just identified. Didn't you say that at the x-intercept, the y-coordinate is always 0? So here's how we're going to find our x-intercept. I'm going to rewrite the equation, but in place of the y, I am going to put 0. Okay, so if I want my x-intercept, I replace y with 0. Why is that so great? Anything times 0 is 0. So check it out. Oh boy, sorry. I don't know why this does this. My screen does this. Let me try this again. 2x, there we go. Minus 3 times 0 equals 6.
What does that say? X minus what?
2x, that's x-intercept, sorry. Are you referring to the title up there, Connor?
No, the top half. Yeah, that. The top half of that.
X, it's a dash.
Okay.
X-intercept. Okay, let's go back. To find the x-intercept, I need to plug a 0 in for y. That's why I plugged a 0 in for y. That make sense? And anything times 0 is 0. So what's going to happen to that middle term? Yeah, it cancels out to be a 0, doesn't it? Because negative 3 times 0 is 0. Okay, so it's just going to be 2x equals 6. How do I get the x by itself?
Divide by 2.
So if I divide by 2, I know that my x-intercept is 3, 0. So what I can do then is I can go to my graph and I can put that point on my graph. 3, 0 is 1, 2, 3, right there.
What's after the negative 3?
What's after the negative 3? That's a 0. I wrote it really neatly the first time, but it kind of got off the edge of the page there. That's
Okay.
parentheses 0. Yeah. So again, so we kind of had some fits and starts there and some questions. So I want to say this one more time, just as smoothly as I can to make it clear. If I'm looking for an x-intercept, I need to plug a 0 in for y and then solve for x. Okay, so in a minute we're going to find the y-intercept. What would you guess I'd do if I'm looking for the y-intercept? I need to plug a 0 in for x. Okay, but there was a question from Lana. Answered it? Okay, good deal. All right, so now let's find the y-intercept. So to find the y-intercept, I need to plug a 0 in for x. So it's going to look like this. 2 times 0 minus 3y equals 6. So again, what's so great about this? Anything times 0? 0. So we're going to get negative 3y equals 6. And then to solve this, I need to divide both sides by negative 3. So dividing by negative 3, I get y equals -2. So I know that my y-intercept is 0, -2. So 0, -2 is right here. And the only thing I have to do now is connect those lines, or connect those points with a hopefully straight line. Something like that. Put arrows on the end. And we're done. Okay, what do you guys think? Do you have any questions? Can I give you a chance to do this working with a partner here in a second? It looks like everyone has a partner. So let's do this. Let's check out example number 3. See if you can do this together with a partner. Go ahead. Of course.
Thank you.
So on this one, walking around, I think we have some pretty good answers going on. We are supposed to use intercepts. So I don't know why this is, but I usually find the x-intercept first. So I'm going to attempt that to begin with. So the x-intercept, to find the x-intercept, I have to plug a 0 in for y. So it's going to be 6x equals -8 times 0 plus 13. And anything times 0 is 0. And so that -8 times 0 is 0. So I end up with 6x is equal to 13. To finish this out, I need to divide both sides by 6. And so my x-intercept is going to be 13/6, comma 0. And there was some stress about, how do I graph 13/6, comma 0? If you use your calculator, you figured out that 13/6 is roughly 2.2, 2.17, 2.1666, something like that. And so all I would expect you to do is come over here to your graph and put the x-intercept over here between 2 and 3. Oh, come on. There we go. See how it's between 2 and 3? Preferably a little closer to 2 than 3, but it just needs to be between 2 and 3. All right. And then the y-intercept. To find the y-intercept, we have to plug a 0 in for x. So this is going to be 6 times 0 is equal to -8y plus 13. And this was definitely a cause of stress because some folks looked at that 6 times 0 and saw, oh my goodness, 6 times 0 is 0, and then the equal sign disappeared, and then you got kind of lost. There was several folks that did that, and as soon as I pointed out that you needed to continue to have the equal sign in there, you got it. So 6 times 0 is 0. So if you write 0 equals -8y plus 13, in order to solve this, I think I would add 8y to both sides. That would give me 8y equals 13. And then finally, I would divide both sides by 8. And when I divide both sides by 8, I get 13/8. So my y-intercept would be 13/8, comma 0. And again, it's a little stressful thinking, all right, what is 13/8? So 13/8 is a little bit less than 2, isn't it?
That's
1.6. Okay, so I'd come over here to my y-axis and I'd say 1.6 is roughly there. Can you see that green dot?
No. Oh, yeah.
How about that? That makes sense? And then I would connect those 2 points with a line. Let's try that again.
Wait, hold on. You had both sides, right? You can't. Can you, no, that's so after I understand how we got, how we multiplied the 0.
Can you talk a little louder? You understand how we were able to plug a 0?
Yeah, I understand we plugged in a 0 to find the y, but I don't really get it after what happened after there. So, we got here.
Okay, slow down. So I plug a 0 in for x.
No, for the y.
So plug a 0 in for x. So you're talking about this right here.
Yeah, I'm really confused on that. So we got 0 equals -8y plus 13.
Yeah. So I see you divided by -8.
Is that wrong?
That's a major problem, right? So when you're solving an equation, what you want to do is you want to deal with addition or subtraction first, right? So probably the very, very last thing you're going to do is divide. So I've got negative 8y plus 13 on the same side. I want to either move the negative 8y over to the other side or move the 13 over. Either, it doesn't really matter. I decided to move the negative 8y over by addition. So you could add 8y to both sides. No, you add 8y. 0 plus 8y. 0 plus 8y. What's 0 plus 8y?
Because you subtracted 8. So
Hold on.
we know 8.
A vertical line looks like this, right? Make it with your arm. Vertical line looks like this. Horizontal line looks like that. Okay, so we're okay on that part. Vertical, horizontal. Okay, good deal. So all vertical lines will have this form. They will all look like this. X equals some number. I just put A there to represent any number. And all horizontal lines follow this form. Y equals some number. Y equals B. So the way that I would encourage you to remember this, I don't know if any of you guys are snow skiers or not. I like to snow ski, so here is my way, or here is a way of remembering this. If you tried to ski a vertical line, you would get X'd out, wouldn't you? Wouldn't you probably die if you tried to ski a vertical line, aka a cliff? If you tried to ski down that thing, absent a parachute of some kind, wouldn't you get X'd out? You get it? Vertical line means you'll get X'd out. Vertical lines are always X equals A. Got it? Now horizontal lines, now if you're a downhill skier, you like to go fast, right? So if you came up to a horizontal slope, wouldn't you look at that and say, why would I ski that? It'd be boring. Get it? Why would I ski it? Why would I ski it? I'll get X'd out. Why would I ski it? I'll get X'd out. Now, if you got a Y and an X, it's a nice angle like this. Well, we'll deal with that differently. That's kind of what we've been dealing with so far. But I'll get X'd out. Why would I bother? Don't want to ski this. Make sense? Okay. So take a look here at number 4. Let's try this one together. We don't need to do this as a table partner exercise. It says graph x equals 2. So here would be my hope as you look at this. I hope that you would look at this and say, hey, that's just x equals, right? There is no y. So if I tried to ski that, I would get x'd out, wouldn't I? There's no y, there's only an x. So if I tried to ski it, I'm going to get x'd out. That means it is a vertical line. Does that connection make sense? There's deeper reasonings for this. This is just a way to remember it. So it's going to be a vertical line at x equals 2. So it looks something like, you can't see that. Let's try that again. All right, x equals 2. There we go. Something like that. Follow that okay?
I don't understand.
You don't understand what?
I don't know. I just don't understand. So anytime it's on the x-axis, it goes this way.
I didn't say any time it's on the x-axis, it goes this way. You know, let me illustrate a few points here. I can give you some deeper reasons besides my ski example. Grace and others that might want to know a little more of a why on this, let me explain this to you. Let's take a look at some points. Let's plot some points that are on this line. For instance, this point right there, what are the coordinates for that point? Wouldn't it be 2, 2?
Yeah.
Okay. How about the coordinates for that point up there? 2, 4. Let's go down here. How about this point right here down below the x-axis? 2, -1. Down here, 2, -4. So are you noticing that as we move up and down this line, the y-coordinates go up or down accordingly? But what do the x-coordinates do? They stay at 2 the whole time. So when you see the line x equals 2, what that's really saying to you is the y-coordinates can be anything as long as the x-coordinate is 2. That's why this is a vertical line. The y-coordinate could be whatever you want. It could be 10, 100, million, -10, -4 and 3/5, whatever it wants to be, but the x-coordinate has to be 2. That's what makes it a vertical pattern. Does that make sense, Grace?
Yes.
Okay. All right, any other questions? Let's take a look at one more. Yeah, one more, I think. Yes, one more. Let's maybe do this one together. So here's my hope. You're taking a quiz, you're working on your homework, and you see graph y equals -5. You'd say, okay, this looks like a line, but there's no x. There's only a y. Why would I ski it? It's going to be boring. Why would I ski it? It's going to just be flat. It's going to be horizontal. So this will be a horizontal line at -5. So 1, 2, 3, 4, 5, like so. Hey guys, really it is the same reasoning for this. If you were to look at all the points on this point right here would be 1, -5. This point over here would be 1, 2, 3, 4. That'd be -5, -5. Any points you pick along there, isn't it going to have a y coordinate of -5? Yes. The x's could be anything. Okay? So, general idea here. This will always have only which variable? This will only have x. This will only have y, right? If it's going to be slanty, what will it have? An x and a y. So vertical means it'll only have an x. Horizontal means it'll only have a y. If it's angled, slanty, whatever you want to call it, it'll have an x and a y in there. Okay? That makes sense? Any questions? All right. So,